Good afternoon, everyone. Thank you for joining us again for the latest in our Passivhaus Retrofit member-led case study series. This session is being delivered by Paul Mallion from Conker Conker Conservation, and I will just hand over to Paul now. Thank you, Paul.
Brilliant. Thanks, Molly. And thanks for the Passivhaus Trust for helping us run this session. We're going to be talking about an EnerPHit in Kingsdown in Kent called Anchors, and we're going for EnerPHit Premium on this particular project. And I'm here with my client, Henrik Carlson, and his wife, Selina, who's out of shot, and our project manager, Andrew Bassant. Andrew has built most of the passive houses in Kent up until 2017. And we built the first passive house in Kent in 2004. So we've worked together on lots of projects. This is our first project with Henrik and Selina. And I'm a building surveyor and passive house designer. So the project we're talking about, just apologies for any noise you might hear in the background. We've got construction work going on to our passive office outside. The project we're going to talk about is a 1950s detached house with cavity wall construction. It's a coastal location. You can see the channel clearly from the site. It has solid ground floor, suspended timber upper floors, traditional cut roof. The cavities were filled with loose polystyrene beads, which caused us some challenges that we'll talk about. The loft was insulated with vermiculite, loose granules. It had the standard issue UPVC double glazed windows. When we took possession of the house, the heating wasn't working, and so we weren't able to do an air leakage test or thermal imaging. So we've had to wait quite a long time to do that. But normally we would do air leakage testing and thermal imaging if the house is habitable and in reasonable condition. This is the front elevation, which faces almost perfectly due south. So we knew we'd have to tackle solar shading. But the rear, which faces north, is where the private garden is, and you can see the view is in shade. So that poses challenges for passive house calculations. We did the pre-purchase survey of the property and found that it had cavity wall tie corrosion. Here you can see one of the cavity ties sticking out through a brick mortar joint and the crack through the brickwork. And these cracks repeated every 3 to 4 courses up the building, getting gradually worse as it went up. And internally, there was a lot of cracking, especially around lintels and the corners. So we factored that into the purchase of the property, negotiated on the price of the house on the basis that it would need a lot of structural repair. This is the cut roof, the traditional purlin and strutted roof. So we did consider going up into the loft when we were evaluating the house and its retrofit potential. This is the view from the front of the house. You can see the English Channel and the ferries go past. It's a wonderful, completely shade-free elevation to the front. This is the proposed plan of the ground floor. So in this slightly shaded grey box is the existing house at the front, and you can see we've almost doubled the floor area with the extension at the back, which is shaded in light blue. And we decided to do an external wall insulation system around the perimeter of the existing house in a matching construction system to the extension. So we've used our preferred form of construction, which is timber I-joists to create the new timber frame structure. And then we've used a smaller grade timber I-joist to create a wrap around the existing building. We like that approach because we can use one firm of contractors to do all of the main construction and insulation work, reduces the number of specialists and sort of slightly smooths out the peaks and troughs of our program. You can see on the plan the extension at the rear at the ground floor is just one big open plan space. Living room is in the existing house at the front, and we created an accessible bedroom, an accessible wet room with a small utility room on the right-hand side of the house. But the utility room wasn't big enough to contain the utilities and plant, so we've moved the plant room up into the loft. Oh yes, there's a very important junction here between the extension and the existing house. The existing house had subsided a tiny bit, was a little bit wonky. We had to make a movement joint at this position, and that's just an important point to tackle from thermal bridging and future avoidance of any cracking in the render. The cavity wall, which ultimately then became enclosed, was one of the key challenges to this project. So being cavity wall construction, there's always risk of drafts through the cavity. And once that cavity becomes an internalized wall, it has to be made airtight from both sides, and any penetrations, door openings, pipes, cables that go through that wall have got to be sealed. And we'll go on to that in more detail. At first floor level, you can see the light blue shaded areas, the extension where we've created a family bathroom and two bedrooms. And the existing bathroom at the back right-hand corner of the house has become a walk-in wardrobe and an ensuite bathroom. And the other bedrooms are retained. There was a very small box room at the front of the house, which has been opened up into a study, which is open to the hallway. And that's now got a pair of double doors looking out, so that can benefit from that beautiful view across the fields and the English Channel. Then we've created a loft plant room using I-joist construction. And headroom is a bit limited. It was quite a challenge to create this from a structural perspective. But you'll note on the floor below that there's a spine wall running down, two spine walls running either side of the staircase, which support the roof structure. We've spaced our new stud walls slightly out from those spine walls. A little bit illogical from a structural point of view, but you'll see in a moment that made good sense from us from an airtightness and services perspective. So this is the cross section side to side through the house, and you can see our thermal envelope is appearing in red, and that's the plant room in the loft, along the ceiling and the external wall insulation and our new floor insulation. So you can see that these are the two load-bearing spine walls, and by separating them from our loft construction, we then created two convenient gaps where we can run plant services, ventilation ducts, without having to break through the airtight barrier. So we're really particular about never puncturing the airtight barrier with mechanical services, particularly ventilation ducts. When we started preparing the building, and we removed two chimneys, and that's always throwing up some exciting challenges. You never know exactly how a cavity wall has been dealt with when chimneys are removed. So we had quite a lot of fiddly repair work to do on this particular flue. And you can see on the right-hand side that we've stuffed the open cavity with mineral wool to stop the polystyrene beads from escaping. We thought we'd be able to retain them on site. This is a close-up of the new cavity ties that have been installed, helical twist ties, and you can see below it one of the old corroding ties. We left the old ties in place where they were on the internal wall. Any tie on the external wall has been cut out. So here's a high-level view of the new extension being constructed, and we've used I-joist balloon frame that avoids having reduces the amount of timber with a balloon frame because these studs go right the way from the bottom plate to the top plate. And then we installed what's called a ledger plate around the floor to support the intermediate floor. Here's the ledger plate going in, and then from that ledger, there are joist hangers and the floor joists span across to the existing building. We found once we'd removed the roof tiles to do roof repairs that the roof wasn't screwed down to the building, and we don't quite know how it stayed there through several hurricanes and the earthquake in Folkestone a few years ago. So we strapped the roof down. Removing the tiles and the battens gave us much better access to do all the eaves work, to get insulation and ventilation over the eaves and fill in any little cold bridges that you might have at the eaves. This is a view from within the new plant room, looking at the new wall we've created. You could call it an internal gable wall constructed from I-joists with I-joist purlins running across. So we've created a nice insulated structure for our plant room with a gap between the horizontal beam and the spine walls for our services to come through. The new roof over the extension was done simply with trussed rafters, and then we insulated that with recycled denim. This is a view of the external wall insulation system. So we used 220mm I-joists screwed with brackets to the existing face of the building, and then we lined it with a breathable board so that we could inject the external wall insulation system with wood fibre. The breather board encloses everything, and then as a second layer, we put a rigid wood fibre over the top, which would receive the render finish. So in this position, there's brickwork visible because this later became a door opening. This is a view of the front elevation where we cut off the overhanging rafters, installed the timber frame external wall insulation, and we later formed a solar shade over this area. But on the sides, we retained the overhanging rafters and we extended them a small distance just to protect the walls. Usually we'd like to extend those rafters about 300 to 400mm beyond the existing wall. But in this instance, because the windows were so close to the eaves, if we'd done that, we would have cut out quite a lot of daylight from the windows. So we ended up with a very small roof overhang. And here's a view from the side during the course of the works where the tiling is exposed for the timber frame to be constructed, just before the overhanging sprockets were attached. We've got roof ventilation. We always counterbatten and batten roofs so you can then stretch your breather membrane nice and tight. Otherwise, there's always an argument about sagging of breather membranes, which never really gets done correctly. The bitumen layer is a ultraviolet resistant eaves tray that drains into the gutters. This shows the insulation material that was delivered just ahead of the injection of the insulation. So this is condensed wood fibre. Then it goes into the machine on the bottom right, which grinds it up and pumps it. And here's the intrepid Antoine from Kithurst Homes. Kithurst Homes constructed the timber frame in their factory, supplied all of the I-joists for the external wall insulation, and they come to site and do inspection. So the cavity wall was an interesting challenge here. This is a photograph of the internalised cavity wall. The cavity ties, you can see the new cavity ties with rock wool bats in there to hold back the tide of polystyrene beads. we hoped that we could keep the polystyrene beads in position and top them up from the top, but while Andrew was supervising the work, we found that that was simply impractical. And so we appointed a specialist contractor who extracted the beads and refilled the cavity with mineral wool fibers. Um, with hindsight, we should have done that right at the beginning and just bit the bullet, get the polystyrene beads out and avoid trying to plug a million holes, which was unsuccessful. So this is a little detail through the cavity wall shown in brown with our new insulation system in yellow. And we've positioned our windows in the new insulation zone. And then we provided an extra little bit of dry lining insulation to the reveals. You can also see at the top of the drawing here a window shutter. All the windows are going to be fitted with vertical rising louver blinds for solar shading and privacy and security. This is a window head detail. So we've got a pocket formed on every window to receive the window shutter with some insulation behind it. And we've had to factor in this cold bridge into our Passivhaus calculations. This is an image showing where we've closed cavities. We tried 3 techniques, but we found this was the best one that was most consistent, where we simply opened up the cavity, cut a thermal block and wedged it in mortar and pointed it up. The proprietary cavity closers didn't always fit because the cavities weren't consistent widths, or they were too loose, too tight, and it wasn't such an ideal situation. So this is really easy in what we're now doing on other projects. Once the cavities were closed, we then painted them with an airtight paint. Some were painted with an airtight plaster made by British Gypsum. Either technique worked quite well. And then the windows, which are fixed on brackets, could then be re-screwed and secured to hold the windows in place. Solar shading. So I mentioned that we're going to have horizontal louver blinds, which retract up into these pockets. We painted the pockets black so that you couldn't see the gubbins that was going up inside there. This is another detail of a blind pocket where we're able to get a bit more insulation. The level of insulation each situation depended on the lintel arrangement decided by the engineer. So we ended up with about 5 or 6 different window head details according to the loadings. On the south elevation, we introduced a shallow roof extension with brackets that mirrored neighbouring properties, so a little bit traditional. And we covered that with zinc. We then, you can see here the PV panels. During the course of the project, Henrik and Selina decided to extend the PV and go for the premium Passivhaus standard. So there's a really good array of PV there. All the windows are inward opening tilt and turn units made by Unilux and supplied by our local specialist called Passivlux Windows. Obviously, they have to be inward opening to avoid clashing with the blinds. And we use handles which are tilt before turn, and that seems to be more reliable than turn before tilt. So air tightness, the strategy here primarily was British Gypsum sound coat parging, which is applied by a thick roller. The contractor that installed it said it might have been easier to trowel it on the wall or spray it rather than roller it. But either way, it seems to be really effective, and it's quite a cheap, simple product. So this was applied to any bare plaster surface, in particular the brick face, which was once the external wall of the house, which is what we're seeing here, which then became internalized. Elsewhere, we just made sure that there was no bare brick or block work. Everything was plastered with a parge coat. It didn't really matter what type of plaster, as long as it had a wet plaster on it that didn't shrink. we could be sure that we were sealing the surfaces of the brick. We found from multiple air leakage tests that if you leave any bare brickwork, air will literally come through the pores of the brick, through the mortar joints or any tiny weakness. And it's worth having the contractor on site during the air leakage test to witness that, because they quite frankly don't believe you that brickwork is porous. At ground level, we decided to use a liquid damp-proof and radon gas membrane up to damp-proof course level. There's a new concrete slab being laid to allow thickness for our floor insulation. This is quite an expensive product, so we didn't use it across the entire floor, but you'll see the amusement of the two builders looking through the back window that during the air leakage test, when we depressurized the building, the damp-proof membrane, which is laid, you can see in this photograph, overlaps the red paint. The damp-proof membrane was sucked up, lifted up the extension lead and the light fittings, and we were really worried we might damage the membrane during the process of the test. So with hindsight, maybe it's worth biting the bullet and doing the liquid membrane to the entire floor. The reason we don't use a damp-proof membrane in some cases is that when it's folded in the corners, it creates many layers of plastic, which is quite difficult to then compress the insulation onto, and you have to wait until you're screeding before the weight of it pushes everything down flat. So a liquid membrane just allows the two layers of floor insulation to go down lovely and tight ahead of the screeding being carried out. This little junction here is at first floor level, looking up at the ceiling, and you can see where the diagram on the right, it's the little gap between our spine wall and the new loft walls, where we had a void that allowed us to run our mechanical and electrical services through the gap without penetrating the airtight layer, which is the membrane on the right. The void between the ground and first floor joists is an area that always has to be tackled very carefully. So here we used black airtight paint at the joist ends, you can see, but the very front joist is sometimes impossible to get behind that. So you either have to remove the joist which is parallel to the external wall, or in this case, we have to wrap it with a membrane and then seal the membrane back to the plaster. So that's the one joist to be conscious of, and it often shows up in air tests as a weakness. This is our finished plant room with a new structural floor, airtight OSB and all the joints taped. And the little white hatch there is an airtight insulated door made by Facro, which leads into the loft spaces either side. This junction is where the roof of the new extension meets the old external wall of the house. And we made this airtight. This is a photograph just before the tapes went on. But during the preliminary air test, we did find leakages around this. So we had to pay extra attention to where the cavity is closed. The cavity closed here is where the brickwork steps back. And that's where we found leakages that we hadn't expected. But by doing the preliminary test, we resolved that and we've got a good result. This is one of the front bedrooms, and you can see around the perimeter we've got what we call an insulated cornice. This prevents the cold bridge where there's a pinch point between the roof and the walls. And you can see all brickwork is covered with plaster, all straps plastered over, and any sockets and switches on the external walls have got blower-proof airtight paint behind them before the back boxes and wiring goes in. This is one of the new bedrooms, and because of the geometry of the house, we had to replicate the insulated cornice through here in order to maintain a constant eaves line around the exterior. Where we punctured that internal cavity wall, we core drilled through the wall, made a sleeve of airtight membrane, slipped that through the wall, and then made it airtight with This looks like about 17 rolls of tape um, on each side. And for the wiring, we did the same. We put a plastic waste pipe through the wall, made it airtight on both sides, and that stood up to our air leakage test. All of the external shutters are electrically operated, so we've drilled through the cavity wall and put a grommet over every junction. So on our air leakage preliminary test, um, we managed to get the required result of 1.0, but we have made some improvements to the property since. So it was a bit miraculous, but also down to Andrew's close attention to work on site and checking everything that we got this result. What we have found from previous projects is if you miss this result at the preliminary, let's say you get 1.2, it can be really, really hard to pull it back to below 1. So yesterday there was another presentation on the Passivhaus Trust by Mark Webb. He had the same problem, and he wanted me to just recommend, from his experience, the AeroSeal product. He's given me these two QR codes. I haven't used it because the system contains undisclosed chemicals, which makes me nervous. But I do know of several projects where the AeroSeal system has salvaged a project and brought it well within Passivhaus tolerances. So look up these two links. And Mike has told me that there's a live installation of this system going on down in Exeter on the 11th of March. One of those QR codes will give you a link to that project. And if you want to visit it, he said you'll be very welcome. I think Molly from Passivhaus Trust might also be putting a training link up on the Passivhaus website. But also, if any of you are interested in historic buildings, there's an old-fashioned air leakage test going on tomorrow in Maidstone. There's a few visitor places being made available by the SPAB. We're working on the Old House project, and that air leakage test starts at 9:30. So Mary Penn at the SPAB technical helpline can tell you whether there's any spare places. M&E, how are we doing for time?
17 left.
Okay. So for the M&E, we've got underfloor heating on the ground floor, and there's no heating to the first floor bedrooms. We've got towel rails in the wet rooms. The mechanical ventilation with heat recovery is a Zender system. That seems to be our preferred approach. We've got one in our office here, and they seem to be really reliable with good technical backup. The heat pump is a fairly new system to the UK by Chronoterm. It's being imported by our local supplier, who is Solaris Energy, and they're much more attractive looking units with really good COP efficiency. We have allowed for some future cooling of the front bedrooms which face south by installing some ducts in case we want to add a cooling duct in the future. And we've got electric louver blinds to most windows, so we can control solar shading really precisely, room by room, according to the climate and the conditions. This is the Chronoterm heat pump. This is the underfloor heating, which is laid in a loose laid mat. There's always a challenge with this where we have a vapor barrier on top. The mat goes down, and the pipe, being very rigid, wants to lift up the mat. So you either have to find some way of gluing the mat down or fixing it in a clever manner to stop it lifting before the screed is laid. This is the plant room under construction. You can see we've got one vent going through the roof waiting to be made airtight. Is it a 300-litre cylinder?
Yeah.
A 300-litre hot water cylinder. OSO seem to be making the most insulated cylinders at the moment. And our plumbers from Solaris are very good at laying out the pipe work and the valves very neatly to avoid any clashes with other services. The ventilation system is running through this area, and there were a few clashes that needed to be resolved, but we've got over that. And this is the state of progress as of last week. So the external insulation has been rendered. The cladding on the outside is sweet chestnut, which is the wood most widely available in Kent. In this instance, we've gone for finger jointed sweet chestnut from Inwood Developments in Sussex. You can see how effective the solar shading is. This is obviously in the winter when the sun's at a low angle. So once the sun rises, we'll get even more protection to the front windows. The porch is still under construction, and we always use galvanized steel guttering. One little concern was that the sweet chestnut does give off a tannin residue when it gets wet. So Andrew came up with a genius idea to put a very small gutter along the bottom of the cladding for a few weeks while the cladding gets wet and the tannins evaporate, and that's avoided any staining of our render. This is a view of the property from another angle, so you can see the solar panels and the cladding. The bottom of the cladding will be cut nice and level once the tannin process is finished. We can't really get a good view of the back of the house, the north elevation, because of landscaping going on at the moment, and there's diggers and portaloos and things in the way. But one of our principles on this project was to keep the architecture very simple so that we could invest the budget in the quality of the materials and the quality of the construction. So summary of the project. Cavity wall buildings, if you're dealing with them, will typically need to be completely replastered from top to bottom. When we've tried to retain plaster, it hasn't always been effective. So if you're doing a retrofit, factor in a lot of replastering. If there's cavity wall insulation, which is loose beads, then it's best to simply remove it right at the beginning of the job and start again from fresh. Where a cavity wall becomes internalized by an extension, then that needs a lot of attention to get that right. If you miss it during the construction phase, it's almost impossible to resolve. We always do a 3D scan of the buildings we work on, and that showed, in this case, that the building wasn't quite vertical. It picked up little problems that we're able to then pass on through the process to our timber frame contractor to deal with those issues. But it's still quite a challenge if your existing building isn't plumb. We had a lot of discussions about whether we would replace the ground floors. We looked at overlay systems. There's enough headroom to raise the floor a little bit with a small amount of insulation. But then we just decided that there was the budget to break the floors out completely and bring it completely up to the Passivhaus standard. But it is a very important point to discuss really early on because of the cost and the disruption. Working out space for your ductwork in an existing building is always a challenge. Finding enough space for your hot water storage and the MVHR unit. The units are large, the MVHR unit, and the ductwork has to go vertically before it can bend. So you have to bear in mind the space needed for that kit. A quick thank you to the contractors. The timber frame fabricator I've forgotten to type here was Kithurst Homes in Sussex. The contractor that put up the timber frame is our local specialist, Passivhaus Contracts Limited, who also won the contract to do the main retrofit internal works. The heat pump was by Solaris Energy. Apex Ventilation did the MVHR. Windows came from Unilux in Germany, and they're supplied and installed by our Kent local specialist, Passivlux. The rendering and the plinths, which is extruded polystyrene, was done by Regency Plastering. And that's the end of my summary, and we can open up for questions. There is another Passivhaus session tomorrow, I believe. So if you've got time, you can grab that QR code and get yourself signed up. I can hopefully then see if there's any questions. So, what key considerations, this is from Louise Charlton, key considerations and solutions are needed for the coastal location? I think the most important thing there is a salty air. And Andrew, you've dealt a lot in coastal situations. Anything else that the grade of steels might be important?
Yeah, the most important thing is the corrosion of fixings. So using stainless steel that is of the right grade. So if it's a fixing, it should be an A4 grade of stainless, not an A2, because they will corrode. And anything that is any metalwork that is exposed should be 316 stainless, not 304, because that will corrode when it's that close to the sea. So that really is the main thing, and also the exposure to the weather and the wind is really making sure that the weather tightness details are up to scratch. You don't get away with very much at all in those locations. So those things need to be really robust.
Brilliant. I think there's also an important point on windows. Timber windows are fine, but if they're aluminium faced windows, the aluminium grade also has to be salt resistant. And although timber windows won't degrade, the hinges and the mechanisms might degrade. So it's a conversation to have with your window specialist. You've also worked on projects which have been sandblasted on camber sands, haven't you? And they've been damaged by
Yeah, Camber Sands Dungeness is about as exposed as you can get, and they really do. The weather really finds the chinks in your armor relentlessly, to be honest.
Ruth Warwick Brown has asked if we can discuss costs at all. So I don't know, Henrik, whether you're happy to talk about. You can say no if you don't want to, or you could give some figures for some elements.
Yeah, I think we've focused a lot with, and I'm not sure if it answers the question, but I try. We focused where we wanted to invest was early in the project with the structure or really insulation work. So I think we have, and that's what I really noticed now is that it takes a long time to. I've never lived in a passive house before, and we've been heating it. The square meterage is about 180 square meters. And we can make it warm with one electric radiator, which is totally fantastic to me. But it took also like maybe 72 hours before that because it moves slowly with all the thermal mass. So yeah, that's what we invested a lot. And now we're at the end of the project and trying to get it over the finishing line. And then we're running on a tighter budget for kitchens and bathrooms and things like that. So I think this is maybe generic building projects. It's very hard to what kind of surprises have we had? Maybe the floor and the roof, and anything else, Elena?
The three-phase electric.
Oh yeah, we decided to upgrade the electricity to three-phase because it both helps with the solar export, as well as we're planning to run 2 electrical vehicles with 2 chargers. So that was also an unexpected, and in retrospect, it would have been better to taken that thing further earlier in the project. But we're getting there, yeah.
And maybe we wouldn't have done the PV so early on. We might have done
Oh
that
yeah,
later.
in terms of holding on to budget, the PV is on the roof now, but if we understood kind of all the implications, then it may not have been so. Maybe it would have made sense to come back with a SCAF and put it on later for cash flow reasons.
Yeah. I think the solar panels were brought on early while we had scaffolding access to the roof, which simplified things. I typically say that the solar panels are the icing on the cake, and you've got to build the beautiful cake first. We're also finding we're going solar on our office shortly, that almost every month we delay the decision is getting a bit cheaper. And normally it's the other way around. So every few months there's another advance in inverter and solar panel technology. So it's not a bad thing to wait towards the end. As long as you pre-plan for your solar, you have roof calculations to show that it can take the weight, and any ducts or cables can be embedded in the roof in good time. But perhaps the final point on costs is that once this is certified and goes on to the international database, there could be an opportunity to put cost per square meter down to help people. So anything else on PV?
Well, on cost,
Cost.
I mean, it is a relatively expensive project, and when a pounds per square meter calculation is done, it will seem to be on the high end. I think that's inevitable. But what I'd actually say is that a lot of that is nothing to do with Passivhaus. It's to do with things that occurred, unforeseen things, things where decisions had to be changed retrospectively. For example, changing the electricity from single phase to three phase. The problems that were had with the cavity wall construction, the insulation in the cavity wall construction being loose and not being bound, as so the general point I would make is if you're retrofitting, if you're doing Passivhaus on an existing structure, is really interrogate the existing structure until you really understand it. And when you think you understand it, you still probably don't understand it. So check it again. And the two things that we missed were checking what type of cavity wall insulation it was, because if we'd appreciated earlier on that it was a loose fill cavity and we were making so many new penetrations through the walls, we would have had a different strategy, in that we would have got rid of it all early on and pumped in something that was bound. And the other thing was we made an assumption about the lintels that were supporting the front windows, which when the house was built, there were no lintels because they built it off the crittle frames and didn't actually put lintels in. And we had to put lintels in retrospectively because we'd assumed that the lintels were there in the first place. So you have to go through every component, one by one, to understand the existing structure, to avoid having to make those on the hoof changes through the course of the project, which inevitably cost more money because you're making those decisions on the hoof. And the other thing with cost is to really interrogate the design. So I think we missed a trick with the electricity supply, for example, because we didn't have a loading calculation early enough to tell us that we needed three phase and we weren't going to get away with single phase. So that was an avoidable cost if we had, if we'd done a bit more of a deep dive into those calculations. So I always say this, I think, in any project, you're better off. Don't think about when the project will start, think about when the project will finish. You're better off starting later and getting a real grip on your costs than you are desperate to get on site, because you'll probably finish at the same time, but you won't have interrogated the information deeply enough before you start.
Yeah, so patience is a virtue on a retrofit.
And another cost thing, but actually how cost influenced how we built, is that we squared up the back extension. We were looking at designs where the back was not square, and I think this is just my intuition because we never really costed up the other options. But I think that would have it simplified the build, I think, and therefore saved cost.
Yes, we were looking at single story extensions or part single, part two story.
Yeah.
And in the end, we just went for a simple box, which was 2 stories with no junctions. And that gave more floor area, but it also simplified the process. Thank you. Okay, so Louise Charlton asks, was any additional ground structure required to support the EWI? No, in that with the timber frame, we simply used angle brackets to fix an LVL sole plate around the building. And then as every stud was installed, each of those studs was screwed directly back into the structure. We had an engineer's calculation for the wind suction and what type of fixing to use. So the whole structure is just hung on the external leaf of the building. There's a question from Maeve. Do we have any pictures of the blinds? Now, The external window blinds are not fitted yet, so we don't have photographs of those. And probably as for budget reasons, that might not be installed straight away. The PV ended up taking preference in the budget. So we don't have pictures of those. But what's the contractor who's installing those?
Love blinds, love your blinds.
Love Your Blinds. Love Your Blinds is the contractor to look up. The air tightness achieved at the preliminary test was 1.0 air changes per hour. So I think the first test on that day was something like 1.1, and we were really, really close. And we managed to find a number of leakage points, plug them, retest, plug them and retest, and that got us down to 1.0. But we also found some other little issues that would have taken longer to resolve. They've been fixed, so we're hopeful we're heading in a downward direction. But our experience is sometimes it either levels out or even gets worse. So we've been really careful about air tightness. A query about the tilt and turn windows. So with a tilt and turn window, you can have there's the tilt setting and the turn setting. So we choose a handle that turns 90 degrees and tilts. Then you close the window, turn it another 90 degrees, and it will turn. Whereas the common is to go to, you have to rotate it to 180 degrees for it to tilt. And it can sometimes get caught in between the two settings. So tilt before turn, TBT, is our preference. I can show the subcontractor list in a moment. We've only done one preliminary air test, and that has to be done at a stage when the windows are in, all the plastering, parge coating is completed. The airtight membrane in the floor is installed, but before any plasterboarding is carried out, so that you've got an opportunity to tackle any problems that you might find. So that's slightly out of sequence to normal construction, because typically on a large project, you might be plasterboarding one area while another area is still under construction and being coated. With a retrofit project, you have to bring all of the airtightness works forward to one specific point in time, set aside half a day when most of the tradespeople will go home, and you can test it with a nice clear sight without grumpy builders saying that they want to get on with their plastering. Have you come across grumpy builders?
Grumpy builders, no.
No.
Never.
I'll just share the okay. Oh yes, so there's another question coming from Scott Smith about the pre-construction testing. When we start a retrofit project, if it's at all possible, we will do an air leakage test and thermal imaging at the same time. So ideally it's in a cold time of year, so we can depressurize the house. We run the heating all night long, then depressurize the house. And whilst it's being depressurized, that will suck cold air in through any gaps, cavities, leakage points, which will show up really clearly on a thermal camera. Then we can reverse the fan, pressurize it, go outside, and we'll look for air leakage points externally. And we've done dozens of these tests now, and every single one shows up something new and exciting that we weren't expecting. Sometimes the properties are surprisingly good. You could test a Victorian house, which is more airtight than a brand new developer home. On other occasions, typically, the biggest problem is loft conversions. If you're testing a house with a loft conversion, it will be diabolically leaky, because that is the problem with British lofts, unfortunately. Other questions coming in now. Martin asks, insulate a timber floor or replace? Yeah, that's a real challenge, actually. If you have a timber suspended floor with a nice large ventilated void underneath it, then you can upgrade that timber floor and retain it. If the void under the floor is really minimal, 100 mil, 150 mil, then we've generally felt that you can't upgrade the floor enough or get enough ventilation through the floor. So we would prefer to replace that timber floor with a solid floor.
On the face of what Martin says there, I would say replace it
Okay.
without more detail. But
Yeah. Okay. I'll just do that subcontract list again. Share that. And I should just put in here maybe the actual timber frame itself was fabricated by Kingsdown Homes.
an extra H on the end of them.
Oh, did I?
No.
Kithurst. Okay. Kithurst have now got a list, but that's just the way it's come back. There we go. Sorry about that. Hopefully people will be able to grab. I'm going to provide the presentation to the Passivhaus Trust once I've corrected the spelling, and we'll be able to grab that.
There was a question I noticed which has disappeared.
Okay.
I thought was quite interesting.
Yep.
It seems to have gone now.
Base timber floor.
But the question was, would it have been more cost effective to knock the building down and start again?
I can maybe say something about that. And that was a big consideration for us.
Okay.
We were mulling over that for months before committing to the retrofit. And now we love it, and it keeps the character. But like financially, very hard to say. Potentially, the only thing also what weighed in the retrofit direction was the planning. It's a very different kind of planning proposition to knock down, I think, and we're not planning experts, but that was the feeling we had. So we felt a bit more secure in the planning and it was a tough site with planning. So
yeah, it's a private road and there's a lot of NIMBY activity, to say the least. Oh, sorry, any neighbours. The VAT is an important factor. So if it is a new build, you can obviously zero rate it for VAT. On this occasion, we took advice from a VAT consultant, and once the property had been left vacant for 2 years, we were able to do the entire project at 5% VAT. Now, that was a really significant factor. Where we do retrofit, you can charge 0% VAT on the insulation elements of the work, but then you need to do double accounting where you have a VAT account and a non-VAT account, and it can get really complicated. So the 5% for the vacant property was a real godsend. And we got a formal statement from the VAT specialist that we could present to each of our contractors so they could present it to their accountants to make sure that everyone was happy with the VAT situation. There are a few other questions. Just one more, actually. A very leaky house, even if it can't reach the airtight standard, is it worth the best efforts? It is. Now, we've had some projects. We've just finished one in Croydon where we got the air leakage down to 1.15, and we went mad to get to that level, and we're just 10% off the a few percent off the Passivhaus EnerPHit-standard. However, they've reported to me that the house is fantastic. It's comfortable. We've finished another one in Leigh-on-Sea in Essex, where the client sent me a message 3 weeks ago to say that his annual energy bill for everything, including charging his electric car, is £200. So that's that. He's got solar panels, which is charging batteries. On that project, the air leakage was 1.5. So we haven't met the Passivhaus standard, but it's still outstanding, and all the systems in the house are still working really well. So it's definitely still worth doing. He just won't get that particular plaque. Obviously, the Passivhaus Trust was established by the AECB, and in some cases we can follow the AECB standard and certify to that standard if we fall slightly short of the Passivhaus standard. So I think we're doing well. We're just about coming up to the 1 hour, and there's no more questions that I can see coming up. So I think we'll probably close it and everyone can go home early for lunch.
I think there was just one question about, are you planning to go for net zero carbon certification?
No, but we do meet the Passivhaus premium standard, which is as close as in reality as you can get to net zero. I'm personally very skeptical about net zero calculations. I think it's a bit of an accountant's exercise rather than the reality exercise. So I'm really happy that we're meeting premium. That's a fantastic standard. And I have more confidence in Passivhaus calculations and methodology than anything that's done in the UK, because it's open source and can be checked and evaluated by anyone. So zero isn't a target.
Thank you.
Pleasure.
So I think that is all the questions. So thank you, Paul, Henrik and Andrew. That was a really great session. And thank you to everybody who joined us today. Thank you so much.
Thank you very much. We'll put the presentation online soon.